record. Hello everybody. Today we'll learn dynamic programming. Example problem in Fibonacci numbers or Fibonacci series. We can computing the nth Fibonacci number recursively, like fn equal fn minus 1 plus fn minus 2, given that f0 equals 0, f1 equal to 1. So we solve this Fibonacci series or sequence or numbers from top-down approach. Okay? If we solve it from top-down approach, we got this. So for fn equal fn minus 1 plus fn minus 2, and recursively fn minus 1 equal fn minus 2 plus fn minus 3. As you can see, fn minus 2 here and fn minus 2 here, fn minus 3 here and fn minus 3 here. So is always repeats the same subtree. Okay, it's a disadvantage. This the algorithm will be int fib int n. If n less than or equal to 1, return 1, else return recursively fib n minus 1 plus fib n minus 2. So this algorithm or this pseudocode or code will solve this Fibonacci series from top-down approach. What is the complexity? The complexity will be order 2 power n. 2 power n. It's a big complexity. The recurrence relations, the equation will be Tn equal Tn minus 1 plus Tn minus 2 plus 1. This one is for addition. Plus 1 is for addition. So from any method you want, the complexity will be order 2 power n. It's not very good, of course, but we know that there is a better way to solve it. Okay? So if we solve it from top to down, it's a bad solving or bad algorithm. If we use computing Fibonacci number using a bottom-up approach, we will see it will be better. So we'll start from bottom to up. We'll start from f0 equal to 0, f1 equal to 1, f2 equal 1 plus 0 equal 1, and so on to get the series. Okay? To get the Fibonacci series. As you can see, if we use this algorithm, okay, from bottom up approach, the order will be, complexity will be order of n. So we convert or we enhance the complexity before from top down, it's order of 2 exponential, 2 power n. Whereas here, order of n, it's very fast here. Also, the space complexity, also order of n. Space complexity, how many variables stored in the RAM, in the memory. Okay? Time complexity, order of n. Also, the space complexity here, it's another parameter for you. Space complexity, order of n also. Because in the top-down approach, we don't have here space complexity. We use memory here. It's also recursive. Not use the memory. But from bottom to up, we must use memory space because we must save the old value here. f0 equals 0, f1 equal to 1, f2 equal f0 plus l1. So we must use or we must store the values of f0, f1, also f2. Then f3 equal f2 plus f1. So every step or every term in the sequence here must be stored in the RAM, in the memory. That's why the complexity of space also order of n. We have n element, so we have n variables inside the memory to be stored. Okay? That's why we introduce space complexity. Okay? All the algorithms before we don't have space complexity, okay? It's negligible, constant. It's constant. It's sorting in place. As you can see, sorting in place, we use only 3 constant. 3 constant is not, it's constant. Space complexity is constant. It's not negligible, okay? But here in this algorithm, when we solve it using memory, the complexity will be better, will be best or better than before, okay? Okay, this method, bottom up, is only, as you can see, order of n. Why is the top down so inefficient? Because we recompute many subproblems, like here, as you can see here. Example, fib5 equal fib4 plus fib3. As you can see, fib4 equal fib3 plus fib2. As you can see here, fib3, fib2, kaza, kaza. As you can see, the subtree of fib3 and below, the same repetition here. Also fib2 repetition here. Okay, so that's why we calculate repetition. We don't care. Cost us a lot of time. So again, we calculate fib3. Again, we calculate fib3 and or fib4 or fib5. That's why will be 2 power n, because we divide it by 2 and make this recursively n times. That's why 2 power n. Divided by 2 and make the calculation n time. The same. That's why we have 2 power n. Okay? Whereas in dynamic programming is an algorithm design technique for optimization problems, often to minimize or maximize. Okay? Like divide and conquer, dynamic programming solves problems by combining solution to subproblems. Okay? Unlike divide and conquer, subproblems are dependent. That's why subproblems may share subproblems. So, here, as you can see, it's divide and conquer algorithm, the same, combining solution to subproblem. But here in in dynamic programming, the sharing subproblems, we calculate it once, because the term dynamic programming comes from control theory, not from computer science. So programming here refers to the use of tables or arrays to construct a solution. So we must save the values. In dynamic programming, we usually reduce time by increasing the amount of space. Okay, so here we use the memory amount of space using arrays or tables, but we enhance we decrease or reduce the time complexity. So we solve the problem by solving subproblems of increasing size and saving each optimal solution in a table or array. So the value of subproblems will be stored in the table or memory. The table is then used for finding the optimal solution to a larger program. When we want to use the sharing subproblem or subtrees, we have its value. So we calculate it once. Time is saved since each subproblem is solved only once. Every tree or subproblems, we calculate it once and save it in the memory or table. When we have the same tree or subtree or subproblems, we use the stored value. So no calculation. Okay? No recursive here. We don't have recursive here. Okay? To find. Okay, sorry. Okay. Any question for here? Any question? Hello? Okay, good. Okay. Another example or problem. counting coins to find the minimum number, of coins to make any amount. Okay, we can use greedy method. Next lecture will explain greedy algorithm or method. Okay, the greedy method always works. At each step, just choose the largest coin that does not overshoot the desired amount. Example here, 31 cents. Okay, we want to find the minimum number of coins to get 31 cents. So the biggest number of coins will be 25. So the greedy algorithms or greedy methods said, okay, always choose the largest coin that fit in your desired amount. Okay, but the greedy method would not work if we did not have 5-cent coins. Example here. For 31 cents, the greedy method gives 7 coins, 25 as the closest to the amount, given amount 31 cents, plus 1 to get 31. So we have 7 coins here. But we can do it with 4 coins if we choose 10, 10, 10, 1. Okay? Okay? الكل فاهمين هون شو عم بيصير؟ جايز شباب صبايا الو
شو يعني قصة الجريدي ميثود تعطيني 10 10 10 1 ولا
لا هيدي كريدي ميثود. لا حنحكي عنها اللكتشر الجاي. كريدي ميثود اول شيء الهدف من الاكزامبل انه بدي اجيب 31 سنت والفراطه بين ايدي هن سنت، 5 سنت، 10 سنت، 25 سنت. اوكي؟ ايه معي 4 كوينز. كيف بدي اجمع ال 31 سنت؟ اكزامبل هذا 31 سنت باقل عدد كوينز. بالكريدي الجوريزم بيقول لك اعطونا الكوينز الاقرب لها. اقرب كوينز لها هي 25، لانه في بايديك مثل الربع والطر والنقش والقصص نص ليره وربع ليره. اوكي، كوينز في 25 سنت. فاذا على 31 سنت نقينا، اذا وي يوز كريدي ميثود نقينا 25 سنت، ما عادش في 5 سنت. هون قايلنا هون the credit method will fail if we don't have 5 cent. اوكي so معنا 5 سنت، شو بيطلع لنا هون؟ مجبور يستعمل سنت بيطلع 7 كوينز، والهدف هو to find the minimum number of coins. So we have another method انه ليه ما نقينا 10 سنت بلس 1 بيطلع 31. هون 4 كوينز. فهون عم نبرهن انه كريدي algorithms, next lecture will explain it in deeply. It's not always the best. Okay? It's not always the best. Okay? طيب شو بنعمل هلا؟ لحظة، الكل فاهمين شو الموضوع؟ الكل فاهمين الاكزامبل عن شو بيحكي؟ الكل صبايا فاهمين شو عم نعمل؟
ايه دكتور.
اوكي، كثير منيح. الهدف نجمع عدد قليل من الكوينز تنطلع الرقم اللي بدنا اياه. اوكي، هذا الهدف. هدفنا our goal to find the minimum number of coins to make any amount desired. اوكي، هذا اكزامبل عم نستعمل انه اذا استعملنا كريدي ميثودز يلي بيقول لنا على طول استعمل اكبر فاليو قريب للديزايرد اماونت، ما على طول ماشي. اوكي، let's continue. Also the credit method also would not work if we have a 21 cent coin. إذا عندنا 21 cent coin ما حيشتغل. Example for 63 cent the credit method gives 6 coins: 25 10 1 فيطلعوا 63 سنت، لأنه على طول بينقي الأكبر بعدين أصغر منه فيطلع 63. بينما we can solve it in 3 coins. If we have 21 cent 21. اوكي، الكريدي ميثود بيقول لك استعمل ماكسيموم كوين هو 25 is 50. بطل في يستعمل 21 كوين لو موجوده. الكريدي ميثود ما بيستعمل 21 لانه 50 بده بعد 13 بده 13 اونلي، ف 21 اكبر من 13 ما بنقيها، بنقي الثاني 13 بنقي الثاني بعدين 1 1 1 بيطلع عندنا هون 6 كوينز. بينما اذا في عندنا 21 سنت فينا نطلعه بثلاثه. كله هذا اكزامبلز لنفوت للبروجرامينج لانجويج، البروجرامينج dynamic programming algorithm. How can we find the minimum number of coins for any given coin set? This is in general. So dynamic programming algorithm is general algorithms, okay? It's better than special case algorithm like CRIDI, okay? Example, if we have this following coins, 1 cent, 5 cent, 10, 21, 25 cent, okay? This is given. We have these coins. We will use 22 cent and 63 cent as our goal. We always need, in simple solution, a simple solution, we always need a 1 cent coin. Otherwise, no solution exists because we must have 1 cent. So, to make K cent, this is a simple algorithm. If there is a K cent coin, then that one coin is the minimum. إذا بدنا نجيب 10 سنت، الأماونت تبعنا 10 سنت وعندنا نحن 10 سنت، فهي 1 coin 10 سنت أو 25 سنت أو whatever، okay? Otherwise, for each value I less than K, find the minimum number of coins needed to make I cent, and find the minimum number of coins needed to make K minus I cent. مثل الجريدي هون عم نستعمل جريدي's algorithm. Then choose the I that minimize this sum. Okay. This algorithm can be viewed as divide and conquer. عم نقسم list. عندنا set عم نقسمها two side. Okay. I cent and K minus I cent. So we divide it, so it's like divide and conquer. This solution is very recursive and call itself. It requires exponential work. هيطلع معنا exponential هون. اوكي؟ اوكي وضحت الفكره. هذا simple solution. هذا بيشبه الكريدي algorithm. Another solution. We can reduce the problem recursively by choosing the first coin and solving for the amount that it left. We have here another solution. Example, for 63 cent, we choose 1 cent coin plus the best solution for 62. Or 1 5 cent coin plus the best solution for 58. Or 1 coin 10 cent plus the best solution for 53. 1 21 and the rest 42. 25, the rest 48. So as you can see here, we will decrease the amount of iteration. So choose the best solution from among the 5 given above. We have only 5 steps or iteration, okay, or loops. So instead of solving 62 recursive problem, we did it with only 5 given, okay. This is still a very expensive algorithm. هون شو صار؟ صار عندنا هون 5 power n. قبل ما يكون عندنا قبل exponential، هون نزل شوي بس بعده exponential. وبعدنا exponential. بس هذه method another solution. هي أحسن من الكريدي بس بعدها مش الأوبتيمال. بينما a dynamic program solution، هلا إذا عم نحله على dynamic programming solution، هو الايديا solve first for 1 cent, then 2 cent, then 3 cent, etc. up to the desired amount. يعني وكأنه عم نشتغلها from down to up approach. Example, and save each answer in any array. We have here from down to up, and the value will be saved in the array. So for each new amount n, compute all the possible pairs of previous answer which sum to n, like we did in Fibonacci. So, for example, to find the solution for 13 cent, First, solve for all of 1 cent, 2 cent, 3 cent till 30. Example. Next, choose the best solution amount. Solution for 1 cent plus solution for 12. Solution for 2 plus solution for 11. 3, 10, 4, 9, 5, 8, 6, 7. Okay? Suppose, example here. Suppose coin are 1, 3, 4 cent. There is only one way to make 1 cent, one coin. To make 2 cent, we must do it by 2 coins. 1 cent plus 1 cent. It's 2 coins. To make 3 cent, just use the 3 cent coin, 1 coin. To make 4, 1 coin. To make 5, we have different solution here. 1 plus 4 give us 2 coins. 2 and the 3 will give us 3 coins. So the first solution, 1 plus 4, is better. So best solution is 2 coins. As you can see, we have 1 cent here, we have 4 cent here. So to get 5, we use only 2 coins, not 3 coins like this. Okay, this is how algorithm of programming done. To make 6 cent, try 1 plus 5, 3 coins, 2 cent plus 4 cent, 3 coins, 3 cent plus 3 cent, 2 coins. So because we have here 3 cents, so to get 6, we only have 2 coins. Best solution. Okay? Etc. etc. Okay? Any question for now? We have still 4 minutes. Oh, let's continue. How good is the algorithm? The first algorithm is recursive with a branching factor of 62. Possibly the average branching factor is somewhere around 31. لأنه divide and conquer. عم نقسم على 2. Divided by 2 around. The algorithm takes exponential time with a large base. With a large base. The second algorithm is much better. It has a branching factor of 5. Okay? This is exponential time with base 5. So هيطلع معنا هون بالثاني 5 باور n بينما بالفوقاني بالحل الاولاني السمبل او الجريدي هيطلع معنا رقم كثير كبير باور n هيطلع 62. هيطلع معنا هون 62 باور n بينما هون عم بيطلع معنا 5 باور n. اوكي؟ فحللنا خففنا كثير بالكومبلكس. بس بعده اكسبوننشال. سو بينما لما نحله بطريقه الديناميك نبلش من تحت لفوق we start from bottom to up we solve it on order nk. Okay, maximum n square nk, where n is the desired amount, is constant, n is constant, and k is the number of different kind of coins, also constant. So this problem, the coin problem, if we solve it in 3 ways, as you can see, the first ways or greedy algorithm will be 62 power n. The second way, another solution will be 5 power n, whereas the dynamic programming will be order of nk, which is constant here. They are constant. K different number, it's constant. N desired amount. The n is the desired amount. It's constant. So this is constant. So we enhance the algorithm better than millions times. Okay? Any question for now? Okay, let's continue. Comparison with divide and conquer. Divide and conquer algorithms split a problem into separated subproblems, solve the subproblems, and combine the result for a solution to the original problem. Okay? Whereas, example, quicksort, merge sort. Divide and conquer algorithm can be thought of as top-down algorithm. Divide and conquer top-down algorithm. In contrast, a dynamic programming algorithm proceeds by solving small problems, remembering the result. We have memory here. we have memory. Remembering the result, we must store the result of subproblems in the memory, then combining them to find the solution to the larger problem, as you can see. So dynamic programming can be thought as bottom-up solution. Okay? End of lecture. Okay. Next lecture will give you the algorithm of programming, the dynamic program. Okay? Any question for now? Any question?
يعني نحن حيلا algorithm فينا نكتبه بطريقة دايناميك نصير هيك هالفكرة.
صحيح وحنحل مشاكل كتير بالديناميك. حنشوف من هلا ورايح حنستعمل we'll use dynamic programming everywhere. حيحل لنا مشاكل كتير و very easy. It's very easy. I will stop now the record.